graders, I'm back. So we are starting a new unit, which means you now get me back with recording your videos. Hopefully everything works well. Please remember that you're always welcome to let me or Mr. Serene know if something's not working with the videos. So if you can't see or if there's something going wrong, definitely let one of us know and we can adjust how we record our videos. On that note, we're starting a new unit. This new unit is mostly about functions. That's pretty much the title of this unit. It also happens to be the title of our first lesson for these notes. So we've got a lot of different things that we're going to be looking at here, but pretty much what we're looking at is the visual representation of an algebraic expression or equation. So we're bringing the visual as well as the algebraic abstract together in one spot, which is what we call graphs. Graphs are a visual representation of the abstractness that is algebra. So we're going to talk about what a function is, what makes a function, what makes it not a function, and all sorts of stuff. These notes are long today because we have a lot to cover, so bear with me, and here we go. So first of all, we need to talk about what a function is. A function is this idea of a machine where you put in things and it gives you things back. For instance, we put in our x values. A lot of times we'll plug in an x value and then we'll get a y value back. It's like this machine that's constantly chugging to give you these values back. The set of all possible x values is called the domain. So everything that we can put in for the x values would be encompassed within our domain. So there are a couple situations that we look out for when we can't plug in x values, and we'll talk about that at the end of our lesson today. But mostly we're looking at fractions because we can't have zeros in the denominator, and we're looking at radicals because with graphs, we can't have a negative inside our square root. Other words that we use for x values are input. We talk a lot about input versus output. We put in a value, what comes out is our output. We plug in x values and we get y values back. Your x value is called the independent variable, whereas your y value is the dependent variable because it depends on what you plugged into this machine, into this function, in order to give you a variable or a value back. There is a definition of a function. Not everything that you can graph is a function. Not every equation that you see is a function. So there's very specific types of equations, very specific types of graphs that are classified as a function. So a function is a relation with one or more variables where each input has exactly one single output. This is going to be kind of a mantra to us. We're going to talk about this a lot when we're saying like, okay, well, does every input have only one output? And we will talk a little bit more about it and talk about it visually. But make sure you have all of that written down. Here it says, again, each x value is only allowed to correspond to one y value. So let's take a look at a few instances. This relation is a function because none of the input values, the x values, has more than one different output, y value. Notice that even though all of the outputs are the same, 0 only goes to 3. 3 only goes to 3, 9, 12, 15. So these all have just one output associated with it, right? If we had 0, 3, and then 0, 10, this would not be a function. As you can see down here, we have 10 going to 3, but then we have 10 going to 15. Not good. This is not a function because we have 10 going to two different numbers. Also, we see that 7 goes to two different numbers down here. So that's what we mean by having a single output. A good visual clue to you, if you're looking at a table of values, is that if you see the x values show up more than once, then it's probably not a function. Whereas if you see the y values show up more than once, it's totally fine. No big deal. Okay. A lot of times when we're dealing with equations, we see a representation that looks like this. It could be f of x, it could be g of x, it could be h of x, it could be a of x, but it's this idea of a function of x. If you ever see notation that looks like this or this g of x guy, that means that it is a function. That means that somebody's already done the work for you and said, hey, by the way, this is a function. And that's it. That's all it means. So you're just replacing the y. This could be thought of as y equals negative x squared plus 4x plus 1, but we instead put g of x. It's because it's kind of, for me, visually, it represents this idea of the machine. So for instance, if we're evaluating and I said, okay, let's find g of 3. G is the name of this relation, the name of this function. And so we're saying, hey, take that function specifically, and I want you to plug in, instead of x, I want you to replace all of your x values in here with 3 instead. This is the operations that happen inside the machine. This is you saying, hey, I'm going to plug 3 into this machine and see what it gives me. So you replace all of your x values with 3. I like to use parentheses just because it helps me keep track of where I'm putting things in. I think parentheses are a safe blanket to kind of make sure that you're keeping track of your negatives, keeping track of your multiplications, and all of those things. Plus 4 times, instead of x, we plug in 3, and then plus 1. This becomes 9, but then negative 9 plus 12 plus 1 is 4. This is what we mean by evaluating functions, is that we now use f of x or g of x or h of x or whatever to be able to define something that is a function. And then in order to evaluate, we just say, hey, let's plug in 3 and see what happens. What is g of 3? G of 3 is 4. Okay, let's try it again. This time we're going to try it with something a little bit harder. You don't have to replace your variable x with a number. You could replace it with another variable, or you could replace it with an expression. So this expression, t plus 1, is now going in for every place that we see x. It's the exact same thought process. So now we do negative, and then in this parentheses, we do t plus 1, squared, plus 4 times t plus 1 plus 1. Now we have to go ahead and expand it and combine like terms, but it's the exact same thought process as what you had from before. Go ahead and fill in the blank spots in this following question to tell me what your fully simplified quadratic equation is here. So to expand this, I'm going to keep my negative outside first. T plus 1 squared is not t squared plus 1 squared. It is t plus 1 times t plus 1. So that's going to be t squared plus 2t plus 1 plus, I'm going to distribute that 4 to both terms. And then I'm going to move on to combining like terms. I need to distribute that negative to all 3 terms. Negative t squared minus 2t minus 1. I'm going to combine the 4 and the 1 here. And then I get negative t squared. Negative 2t plus 4t is positive 2t. And then negative 1 and 5 combine to be plus 4. So g of t plus 1 is equal to negative t squared plus 2t plus 4. So we've covered a lot in this first page already. Evaluating is pretty straightforward. I'm pretty sure you've maybe seen it in the past. If not, no big deal. We're going to continue to practice it. We are right now going to continue practicing what is a function and what is not a function on the back page. So determining whether a relation is a function. We're going to add circles, arrows, lines, or etc. to demonstrate why each relationship is or is not a function. If we have a table, as you can see over here with A and B, you want to review the columns. The relation will not be a function if any what value corresponds to more than one different other value. Referring back to our previous notes, you should have said if any x value corresponds to more than one different y value. This is the idea, is that if you have an x value go to 2 different y values, it's no bueno. It's not a function. Here, it's fine. -1 always goes to 1. 0 always goes to 0, and 1 always goes to 1. Yes, 1 has appeared twice, but it's appeared twice on the y column, and so it's fine. This is, yes, a function. Whereas b, you can see that 2 goes to 11, but then 2 also goes to 10. And so because of this, it is not a function. No, not a function. Okay. So this is one way you might be shown a relation. As you saw on our previous page, we were given a table of values just in horizontal instead of vertical, and it had that same issue that 10 went to 3, but then 10 also went to 15. So you had an x value of 10 going to 2 different y values. You can also be given your relation in set notation. Whenever you see these curly brackets, it's set notation. And a set is just like what it sounds like in English. It is a collection of things. And in this case, it's a collection of points that represent a relation. So we have to review each ordered pair. This is an ordered pair. This is an ordered pair. This is an ordered pair. A coordinate, right? The relation will not be a function if any x coordinate corresponds to more than one different y coordinate. Hopefully we're seeing the pattern here. We're recognizing this. So we need to look at each of our x values. 3 is not repeated here. So we know that 3 is only going to 3. 4 is not repeated. 4 is only going to -1. And 2 is only going to 3. So this is a function. Whereas 1 goes to 8 here, but 1 goes to -3 over here, which means it's not a function. Our x coordinate 1 is going to 2 different numbers, and that's not good. The next way we could be given a relation is by a graph. We are going to use something that's called the vertical line test. If you are a visual person, I'm a visual person, this is how I think of a function every single time. When I'm looking at these tables, when I'm looking at the points, when I'm trying to remember what makes a function and what doesn't make a function, I think of the vertical line test. Because the vertical line test is a way for you to check in on, does an x value go to more than one y value? So the vertical line test is you take a line, and typically you'll draw it, but I like to use a pencil or a pen sometimes, and I go across the graph with this pencil or this line, and I say, does this line hit the graph in more than one place at once? And notice that as we slide this pen from left to right, it only ever hits your parabola at one spot. And so this parabola passes the vertical line test because it only hits it in one place at any given point, which means it is a function. So the relation will not be a function if a vertical line ever touches the graph more than once. So again, recognizing patterns, we try this again with this relation right here. This is the inverse of a parabola, which we'll talk about by the end of this unit, what an inverse of a function is. And this is an inverse of a parabola. And the inverse of a parabola is not a function. Because as you're sliding this pen from left to right, you can see that this idea of a straight line touches in more than one spot. It touches here, and it touches here. So in more than one spot at any point in the graph means it is not a function. Not a function.